This equation that we saw in the last unit is the basis of what is called the expected utility theory of decision making. This theory relies on 5 principles or 5 axioms that underlie rational decision making. Here are the 5 axioms. The first one is called completeness, the second one is transitivity, the third is substitution, the fourth is continuity, and the fifth is monotonicity. We're going to focus on the first 3 because the last 2 are really there for mathematical tractability of the model, and they don't have interesting behavioral insights coming out of those. Let me start off with completeness. It's a very simple axiom. Completeness says that when I give a decision maker 2 options, let's say X and Y, the decision maker should be able to articulate a preference between those 2 options. In other words, they should either be able to prefer X over Y or Y over X, or they should be able to say that they're totally indifferent between those 2 options. What cannot happen is for the decision maker to say, well, gee, I don't know which one to choose. Now, we've seen in some of the previous units that in cases where there is too much information or when there is overload of data, consumers might actually choose to not choose because they're confused, and that would be a violation of this simple axiom. Let's move on to the second axiom, and that's called transitivity. This again is a very simple axiom, and it says the following. Let's imagine a decision maker prefers X over Y and then chooses Y over Z. What this axiom says is, in that case, X should be preferred over Z. Now, this sounds fairly obvious. If you prefer receiving $100 over 50 and you prefer receiving 50 over 20, it makes perfect sense that you want to receive 100 instead of 20. But there are many different domains in which this particular axiom is violated. And I want to show you one simple example. Let's imagine that you are looking for a research assistant, you're looking to hire someone, and you have 3 applicants, Mr. A, Mr. B, and Mr. C, and for each one of them you've got data on 2 attributes. The first one is their IQ, which is based on a standardized IQ test. The second one is the number of years of work experience that these people have. And let's say you've got a very simple rule. You want to choose the most intelligent person, and if in fact you have 2 people of equal intelligence, then you will choose the one with higher work experience. Now, if you look at this data, you've got 3 people. The person with the highest intelligence score also has the lowest experience. And this is a fairly standard kind of a setup that you might expect in the real world. Now, here's the interesting part. We also know from the history of IQ tests that they're not very reliable. They're not very diagnostic. In other words, a score which is different from 10 points from each other might not really mean that one person is actually smarter than the other one. So if I look at these data, 120 is about the same as 110. 110 is about the same as 100. So if I apply my rule of decision making, here's what it's going to tell me. It's going to tell me that I will prefer Mr. B over Mr. A because they're about equally intelligent, but B has more experience. And likewise, I would prefer C over B. However, if I now look at the whole picture, I will end up preferring A over C because now the difference between 120 and 100 is significantly large, that by my rule, I end up picking the more intelligent person. So this is an example of the violation of the transitivity principle, and it happens in a number of different domains. Essentially, what's happened here is that the context has conspired in such a way that the decision maker views the attributes differently in making choices. So the literature is replete with examples of the violation of this particular axiom. Here's the third and more important axiom, and this axiom is called the axiom of substitution. And it says the following. If I have 2 options, X and Y, and I'm indifferent between X and Y, then I should be indifferent between 2 lotteries that have X and Y as their prize. So for example, if I love an apple as much as I love a banana, then and you come to me and say, well, if we're going to toss a coin, in one case, if it's heads, you're going to get an apple. In the other case, if it's heads, you're going to get a banana. Then I should be indifferent between those 2 lotteries because I was indifferent between the 2 prizes to begin with. Now, one corollary of this particular axiom is something called the cancellation principle. And cancellation says that if I've got two options and I remove something identical from those two options, I should still now have the same preference between those two options as I had before. Now, it turns out again that this principle, the principle of cancellation, is often violated in a lot of decisions that we make. And perhaps the most famous demonstration of the violation of this principle was done by Maurice Allais in something that is known as the Allais paradox.
So in the Allais paradox experiments, there were two groups of participants. For a moment, let's focus on group 1 on the left-hand side in the blue box. They were given the choice between option A, which was a sure shot 1 million, or option B, which was a risky prospect, as shown here, 10% chance of 2.5, 89% chance of 1, and 1% chance of nothing. A second group saw a different two choices of gambles. Option A for them was 11% chance of 1 million and 89% chance of nothing. Option B was a 10% chance of 2.5 million and a 90% chance of nothing. In his experiments, Maurice Allais found that in group 1, most people picked option A. After all, they were getting $1 million with certainty. Why take a risk? Whereas in the second group, in the yellow group, most people picked option B because the difference between 10% and 11% didn't seem that large. And in fact, at that level of risk, in option B, they were going to get 2.5 million as compared with 1 million. Now, on the surface, this looks like a very rational choice to make, except for the fact that Maurice Allais had set up these experiments such that the two choice sets in the blue box and the yellow box were actually identical. So for example, if I look at the blue box and in option A, remember it used to be 100% chance of 1 million, I now rewrite that as 11% chance plus an 89% chance of 1 million. And I do the same thing in the yellow box. I look at the 90% chance of nothing and I break that down into 89% chance of nothing versus a 1% chance of nothing. Now, I can then apply the principle of cancellation from economics, and I can look at the left-hand side, the blue box, and I can say, well, gee, both option A and option B have this one element in common. In both options, there is an 89% chance of winning 1 million. And so I can delete that 89% chance of winning 1 million from both option A and option B and replace that with an 89% chance of 0 in both conditions. And if I did that, I would get the two groups now looking like this. Option A in the blue box is 11% chance of 1 million versus an 89% chance of nothing, which is the same as option A in the yellow box, in the yellow group. And option B in the blue box now is 10% of 2.5, 89% of nothing, and 1% of nothing, which again is identical to what we had in option B in the yellow box. And so we had a situation here where the two boxes, the two choice sets were identical, yet in the left-hand side, the blue box, people were picking option A, whereas on the right-hand side, they were picking option B. This was a violation of the axioms of rational choice.
I'd like to leave you with one thought. We've talked about the 4 C's of rationality, and we've made the point that all of these 4 C's need to happen for people to display rational behavior. Now, people routinely violate axioms. People routinely do not behave in consistence with those 4 C's, but they're just being people. Are they being irrational? Irrationality has a very strong connotation to it. It suggests that people are making a mistake. And in my opinion, if you have a theory that doesn't account for the way in which people make decisions, perhaps that's not the right theory to explain human behavior. Perhaps it's not people that are being irrational. It is the theory that is perhaps not rational. And that's why a behavioral approach to economics tends to be the richer approach.